In this video, I'm going to introduce the inscribed angle theorem. So an inscribed angle is just an angle whose vertex sits on the circle. And what the inscribed angle theorem says is that if you have an inscribed angle who subtends an arc, who subtends the same arc as the central angle, then the central angle will be double that inscribed angle. So let's say this central angle is 40, then the inscribed angle will be 20, always. Now let me prove it to you. There's going to be 3 cases that should cover every type of inscribed angle theorem, inscribed angle and central angle, to prove the inscribed angle theorem. So let's say there's an inscribed angle who is like that, with a central angle like that, where the inscribed angle one side of the diameter of the circle. So let's call this theta and this alpha. To prove that this angle is double this angle, or this angle is half that angle, what I'm going to have to do is, we know that this is just a radius, and we know that this is just a radius, so that these angles must be equal. So this must be theta. And since this angle right here is 180, this angle must be 180 minus alpha, because they are supplementary. So we have theta plus 180 minus alpha equals 180 degrees, because the sum of the interior angles of a triangle all add up to 180 degrees. Subtract 180 degrees from both sides, and combine like terms. We get 2 theta, and subtract alpha from add alpha to both sides. We get 2 theta is equal to alpha, or theta is equal to 1/2 alpha. That's one case. Let's go to this case. Well, let's say in the circle, we have an inscribed angle, and we have a central angle like this, subtending the same arc as this inscribed angle. And this is theta, and this is alpha. So to prove that that theta is half alpha, I'm going to use the proof that I just proved to prove it. So what I'm going to do is, I'm going to draw a diameter, and I'm going to call this theta 1, this one theta 2, this alpha 1, and this alpha 2. So we know that theta 2 is going to be half alpha 2. And we know theta 1 is going to be half alpha 1. So if we get half theta 1 plus half theta 2 is equal to alpha 1 plus alpha 2. Alpha 1 plus alpha 2 is just alpha. And we can factor out theta 1, we can factor out the half on this side to get theta 1 plus theta 2 times half is equal to alpha. And theta 1 plus theta 2 is just theta, so half theta is equal to alpha. That's the second case And for the third case, it's going to be a little bit different. Let's say we have a circle, we have a central angle, and we have an inscribed angle like this. Call this theta and call this alpha. The way to prove it, I'm going to use the first proof. Let's draw a diameter. Let's call this theta 1. And let's call this alpha 1. Let's call this alpha 2. My camera ran out of storage. But where was I? Alpha 2. This is alpha 2. And this is theta 2. So, we know that theta 2, half theta 2 is equal to alpha 2. And let's see, from there, where did you go from there? I'm trying to remember. Half theta 2 is equal to alpha 2. And let's see. Theta 1 plus theta 2 is equal to alpha 2 plus alpha 1. So this inscribed angle, half of that is equal to alpha 2 plus alpha 1. Well, we know alpha 2 is half theta 2, and we have half factored out theta 1. We could factor it in, expand it, plus half theta 2. It's a little messy. We can subtract half theta 2 from both sides, and we get that alpha 1 is equal to half theta 1. And that's the inscribed angle theorem.